Hey everyone, welcome back to my channel. In the last video, we walked through the general process of system design. So in this video, and maybe the next few after it, we are going to do a deep dive into each step of that process. So without further ado, let's jump right in. So let me start with a recap, right? So our system design process follows a clear structure. First, we do a scenario analysis where we identify the functional and non-functional requirements. Optionally, we'll do a back of envelope calculation, and then we move into the core design, which is the overall diagram, right? So once we have that, we define the API contract and the database design. And finally, we do a validation step. We go back to the requirements we set at the beginning and check whether our design actually meets them. So think of it like a classic essay structure. We have introduction, have body, and then conclusion. Or more specifically, start with a problem definition, move into the solution, and then finish with verification. So first, let's talk about scenario, right? Like scenario analysis. So why scenario analysis matters? So this step is actually extremely important because it sets the foundation um, for everything that follows, right? So if you don't do this while doing an interview, you will end up needing a lot of more back and forth with the interviewer to uncover the hidden problems and requirements. So that wastes your valuable time. So getting good at this really comes down to two things, right? So mastering a variety of analysis techniques and building up your exposure to different types of problems. The more problems you've seen, the better your instincts will be. We will explore that more later. Remember last time, like remember before we talk about like there are functional and non-functional requirements. So for functional requirements, the very first step is to identify the core features. So when you are given a problem, right, the first thing to do is identify, um, like for example, if the problem is designing YouTube, the core features are uploading and streaming videos, right? And if the question is designing a payment system, the core feature is processing payments. So a user pays for something and then gets a result back. So this is like pretty straightforward at a high level, but there are a few key things I think are especially important when analyzing functional requirements. So step one is you need to figure out who is the actual user. So it is a like is it a real end user or is it just some other entity? So for traditional large scale system design problems like design YouTube, design Netflix, the user is typically a real user, like real person, right? Everyday end user. But there's a growing trend in interviews. Problems are shifting from these large systems toward small, focused ones, right? The reason is pretty simple. In a 45 to 15-minute interview, if you try to design all of YouTube or Google Drive, and then the discussion tends to stay surface level, you end up just scratching the surface instead of going deep in any area. So now you are more likely to see problems like, designing a payment system, designing a monitoring system like Datadog, or designing a I don't know like an IM system, right? And with these smaller systems, the actual users is often not a real world end user. So, for example, for an IAM system, um, or a payment system, the user is often an internal developer because it's just a component within a large platform. Um, there is even another scenario. So sometimes the real user isn't even a human. So for a payment system or another service to service integration, the actual consumer might be another service making API calls. So this is very common in today's microservice architecture. So getting clarity on who the user is upfront is very critical because it changes everything downstream, right? Okay, and then before we move on to the next topic, one thing I want to point out for this specific category is that also many times different user types means different characteristics. So here's why this matters, right? Because different user types means like so for example, real end users come with their own read and write patterns that we will discuss in a moment. And eternal developers, on the other hand, at most companies, you are looking at maybe 100,000 of them at a very large organizations, which is still relatively small number compared to consumer scale. But there are some other reliability considerations that you might have to think about, because like a lot of times internal developers are working on a platform that are used by a lot of other companies. So if the internal platform fails, and then the whole company goes down, right? And if the user is an internal service, the key characteristic is that it can generate a massive number of requests in a very short period of time, right? So think of a monitoring system. The machines are sending data continuously, non-stop. So each of these user types leads to very different design considerations. So that's the last point I want to point out for this category. Yeah. So once you know who the user is, the next step is determining how they interact with the system, right? For a traditional consumer-facing product like YouTube, the interface is a UI, web app, or mobile app. That's your front end in general sense, right? But there are other interaction models as well. If the users are developers, they might interact through a CLI, a command line interface. If the consumer is another service, there's no UI or CLI involved. Communication happens through an API server with services calling each other directly. And there are also IoT scenarios, Internet of Things scenarios. For example, for payment systems, the terminal might be a POS machine. So mobile phones, broadly speaking, are also type of like front end services, right? And after you have identified the user and the communication model, the next question is, what are the key interaction flows? YouTube might have dozens or even hundreds of features, right? So for example, login, logout, search, recommendations, comments, YouTube Shorts. But 45 to 50-minute interview, you can't cover all of them. So you need to confirm with the interviewer which specific flows you should focus on. For a video platform, it's usually upload and download. For a payment system, it's the pay action itself, right? But don't guess, just ask. This requires some back and forth discussion with the interviewer to nail down exactly which operations you should care about. The last key piece of functional requirement analysis is understanding the read and write patterns. This is something you can and actually should establish during this early discussion with the interviewer, because it has a huge impact on your design. So look at each interaction flow that we set up in the previous steps and ask yourself, is this read heavy or write heavy? For example, like uploading video is clearly write heavy. You are constantly writing data to the database, but the frequency might not be that high, right? But when the user views their uploaded videos, that's read heavy, and that's expected to happen more frequent than uploading videos. So for most online services, reads far exceed writes, but having this kind of clarity early, will help you guide your back of the envelope calculations and your architecture decisions later. So yeah, just ask. Cool. So now let's talk about our non-functional requirements. So I'm pulling this criteria from the book Designing Data Intensive Applications, which is widely regarded as a great reference for system designs. So let me walk through the key ones and how I typically discuss them with interviewers. The first and arguably probably the most important ones is like availability or reliability. So this applies to virtually pretty much every system because like, which system doesn't want availability, right? The key metrics here is SLO, so service level objective. It defines how available the system needs to be. So how much downtime can you tolerate per year? Um, and it's measured in number of nines. So for example, 99.9% availability means roughly 8.8 hours of downtime per year. And 99.99% means the system is pretty much up almost all of the year, which is only about a day of a lot downtime. So I usually bring this up during this scenario analysis phase. I will tell the interviewer I'm familiar with SLOs and suggest setting it something like 99.9% or 99.99%. The exact number isn't as important as demonstrating that you understand the core concept and have used it in practice. We will also cover later how to actually improve availability during the validation phase. For scalability, so scalability means that as the system load increases, the system must be able to handle it, right? And the most critical thing here is to define what load actually means. Now, in most system design problems, the load comes from user inputs. So broadly defined, since the user could be a person, a developer, or another service, right? The way we quantify this is through QPS, so queries per second. When QPS grows, our system needs to scale accordingly. So scalability generally breaks down into two dimensions. Server-side scalability, which we handle with API gateways and load balancers, and database-side scalability, which we'll discuss shortly. Consistency. Consistency becomes a concern when your system has multiple components storing data in different places, multiple databases, message queues, caches. If there's only just one database instance, data is inherently consistent. But as soon as data lives in multiple locations, no matter the reason, right? Like whether it's because reliability, whether it's because you want to do database data sharding, you will face inconsistency issues. The key question to discuss with the interviewer is when can the system tolerate some degree of inconsistency, right? And you can ask questions like when do we absolutely need strong consistency, or is eventual consistency acceptable? So for example, a payment system likely needs strong consistency, while a social media feed can usually tolerate like eventual consistency. So talk with your interviewer, right? Latency, right? So latency could technically fall under availability, but I prefer to call it out separately because it has its own specific metric, which is the 99th percentile or P99. So this means like 99% of the request needs to complete within a certain period of time. So for instance, if your P99 latency is 20 milliseconds, that means 99% of all requests must finish within 20 milliseconds. The lower this value, the better your latency. There's also the 50th percentile or P50, which captures the medium experience, right? So some people group SLO and P99 together under availability, and that's fine. I keep them separate because in my experience, many interviewers treat them as distinct topics. So beyond this, you can also bring up things like security, privacy, observability, and maintainability. There are a lot of possible discussions points here, and remember to use your strongest knowledge area. So you can cover a lot of things just show your strongest point. Okay. Someone may ask, right, why bring this up at all, right? Because these are some kind of hidden metrics. So sometimes people are wondering why should we all of this up in the interview? So there are two reasons, right? So first, it is a chance to demonstrate your knowledge. these metrics are extremely relevant in day-to-day engineering. So, if you work in a tech company before, you will likely have to monitor SLOs, you will have to track latency, and you care about uptime, right? So showing the interviewer that you understand the signals, and you have this kind of like critical experience is very important to build the very first like great impression, right? And the second reason is it actually gives you concrete acres for the validation phase. So you write down these numbers early, and this is kind of like a contract you set with the interviewer. And later, when you are validating your design, you can just go back and go through each of these criteria one by one, and then verify that your architecture meets each requirement, which gives a kind of a very organized impression, like style of your entire interview process. Cool. And finally, let's talk about back of the envelope calculations, which is I think is a little bit conventional. These are being tested less and less in interviews nowadays. So if you are interested, I can make a separate dedicated video walking through a few use cases on how to actually run the numbers. But for now, I will just give you some of my personal ideas, right? So to do the back of the envelope calculation, there are typically two types of systems, right? So there are online systems and offline systems. For online systems, the ones where real users are interacting with, there are basically two things to estimate. The first is QPS. So you ask the interviewer for the number of daily active users, estimate how many times each user performs a given operation per day, and then calculate the queries per second. As a bonus point, when it makes sense, calculate both the average QPS and the peak QPS, right? So during high traffic events, think like Black Friday or similar, traffic can spike dramatically. So a common approach is to multiply your average by a factor of 3 or 5 to estimate the peak, right? These are all assumptions. So as long as they're reasonable, that's fine. So run the numbers by the interviewers, and if they agree and if it makes sense, you are good. And the second metrics for online systems are storage volume. So you have to ask the interviewer about daily data volume, project it out over, say, 10 years, and then you will get a rough storage estimate. And now I'll be honest, because at this stage, the storage estimate isn't super meaningful because you don't yet know your database design, so you can't estimate storage accurately without knowing what database you are using, right? So, but that said, storage volume does lay the groundwork for database sharding later. If the data is too large for a single machine, you will need to distribute it across multiple nodes. So, definitely this is sometimes necessary in certain scenarios. So for offline systems like web crawlers, QPS isn't as relevant. What matters most is the total data volume. And remember the exact numbers doesn't matter as much as the order of magnitude. So, the difference between 10 to the fifth and the 10 to the sixth is significant and will affect your database selection. But don't obsess over whether it's like, I don't know, like 105,000 or 110,000. That doesn't change your overall design, right? Here's some of my personal strategy. What I typically do interviews is I tell the interviewer that I know how to calculate QPS and the storage, but I like to defer it and draw the overall diagram first. The reason is twofold, right? So first, it's about time management. I would rather spend the limited interview time on the design itself. So I show the interviewer I know what to calculate, but suggest we focus on what's more valuable. Because imagine two cases, right? Like imagine you did a thorough back of envelope calculation, but you didn't finish up the overall diagram, And then another scenario is like, you did the overall diagram nicely, and then, you come back with the back of envelope calculation, but didn't finish it. Like which scenario looks better? I would like, definitely choose the later, which is like, finish the overall diagram, right? So, I just want to leave the time for some most important things. The second reason is like in practice, very few interviews actually deep dive into database sharding, implementation details like consistent hashing or anything else. So the storage calculation, while useful in theory, often doesn't come up in a quite meaningful way. Again, the bottom line is like back of the envelope calculation is something you can do if you have plenty of time, but if it's not like critical. So focus your energy on the design itself, and that's usually how I would approach it. Right? I would tell the interviewer, if I want to do the back of envelope calculation, I would calculate QPS and storage, but because time is limited, can we park this discussion and then move on to the overall diagram, and if we have time we'll go back. So this is kind of like my personal strategy, right? Okay, so that covers scenario analysis, probably the first and arguably most critical step in any system design interview. So as a recap, right, so remember, identify your user, understand your interaction model, and nail down the key flows, and then analyze read and write patterns, right? So to establish your non-functional requirements, these are some of the considerations to cover. And if time allows, do a quick back of the envelope estimation. Get this step right, and everything else will flow much more smoothly. In the next video, we'll dive into the next phase of the process, which is the I guess like this is the most like the meat of the discussion, right? Which is the overall diagram. Yeah, thanks for watching, and I will see you in the next one.